The graph represents the position x as a function of time t of a particle and moves along the x-axis. At t equals 0, the particle is at position x equals -3 meters. At both times t equals 1 second and t equals 3 seconds, the particle is at position x equals 0. Using features of the graph, justify whether the particle's velocity and acceleration are either positive, negative, or 0 at times t equals 1 second and t equals 3 seconds. Justification should use qualitative reasoning beyond referencing equations. So as we can see, at time t equals 1 second, x is increasing, which means it has a positive first derivative, and because velocity is the first derivative of position, velocity is also positive. Now, at time t equals 3 seconds, right, we see that x is decreasing, right, and for the same reason, velocity will be less than 0. Now for the domain of x, right, from 0 to 4, we see that it is concave down, which means that x double prime of t is less than 0, and because a of t is equal to x double prime of t, a of t will be less than 0. That is for both t equals 1 second and t equals 3 seconds. Now for part B, the motion of the particle is described by the equation x of t equals -t squared plus bt plus c, where b and c are constants and are not necessarily positive. Derive equations for both the velocity v and acceleration a of the particles as functions of time. Express v and a in terms of b, c, and t as appropriate. So remember, v of t is equal to x prime of t, first derivative of position, which means that it is equal to -2t plus b. Remember, we just use the power rule for this. And because a of t is equal to v prime of t, a of t is just going to be equal to -2. Remember, it is important to start with, on the AP test, just the base equations, a of t equals v prime, v of t equals x prime, before differentiating. To describe the motion of a second particle moving along the x-axis, a term d times t minus 2, where d is a positive constant, is added to the equation given in part B for the first particle. Describe how the graph of x of t for the second particle is different from the graph given for the first particle in terms of when the second particle's position is 0, and justify your answer. So, for d times t minus 2, right, we can see that when t equals 2, this will be equal to 0, right? So that means that it won't add anything to the equation for part B, and position will be the same here. However, when t is less than 2, right, remember d is positive, and something that's less than 2 minus 2 will be negative. So positive times negative is negative. And so if we're adding something negative, that means we're subtracting, and therefore this will be shifted this way, right, because it'll be less. However, when t is greater than 2, right, like at x equals 3, or t equals 3, this will be positive, and therefore positive times positive is positive, and we will be adding. So it will be at a time greater than 3 when this is equal to 0. I hope this helped, and if you guys need help with another physics problem, just let me know in the comments. I'll see you guys in the next one.